Hey guys, this project is about analyzing the driver's performance using OBD. So OBD port is typically located in the driver's footwell area. So this is the dashboard under which we can directly plug in. This is how the OBD device looks like, and it can be directly plugged in as shown in the video. And once plugged in, you can see that the OBD device will be powered up using uh, using the car's battery. And once it is powered up, we can connect it through our Streamlit driver and performance analysis dashboard. So that I will show you in a minute. So here we are trying to analyze the data. We are trying to read all the data from the OBD device. We are basically trying to read different types of data like RPM, speed, total valve, position, coolant temperature, engine load, runtime, etc. So all these values also are plotted onto the graph. I will show you in detail how we are plotting the graph and everything. So the continuously it will be reading the data in real time. We are even logging how much uh, data count we actually we're calculating how many data points we collected, and what is the current value, what is the average value. All these values are we are taking it here. This is one of the demo where we found that our engine overheated because of the coolant temperature went above 95 degrees Celsius. That is the threshold which we gave. So this is the DriveGuard website which we came up with, where the user can select the device on as shown on the left hand side. Once the user starts the trip, the data gets starts. We start reading the data from the OBD device which is connected to the car. So these are the different parameters which we are reading, and we are plotting against the time. We are basically reading RPM, speed, total position, coolant temperature, engine load, runtime against the time. So here, as you can see, we are even counting how much data points we collected. We are trying to read the data per second. It can be increased as well as in when required. But for us, we just wanted to get the data per second. So here we are even showing the metrics of uh, the average values of RPM, speed, total position, etc. And even we are displaying the current value, and we are plotting against the time. This is the maximized view of each one of the parameters which is plotted against the time. Here we can see the time at which we got that data point, as well as what is the value that was read from the OBD device. This is total position versus time. This is coolant temperature. Currently it is 98 degree Celsius, which means it is above the threshold. So our threshold we have hard coded it as 95. This is RPM versus time. And this value is speed versus time in the maximized format. So this was the initial dashboard, which actually looks like this, where we are logging all the current values of all the 6 parameters, and we are even calculating the average and the how much count. So there was one overheat engine detected at this particular time. We are even logging what is the time which we got that particular temperature engine overheat temperature detection. Here you can see we actually can collect the data for two devices. Right now we have added two devices. One is for the two-wheeler and another is for four-wheeler. So once the user clicks on the start trip, that's when the data it connects to the OBD device and start collecting the data. So right now I have stopped the data collection, and I can we have implemented all these 5 algorithms. One can select any of the algorithm and click on generate trip report. It takes a few seconds, and whatever during the entire trip, whatever uh, anomalies which got detected will be detailed report will you can find it here. Now we are moving on to SFD implementation, where we are considering external factors to predict if the vehicle needs maintenance or not.
Hi, welcome back. Now we have upgraded ourselves to a car now. We are trying to test out how our project will work with the car. So what we are trying to do is same concept. We have 4 sensors out here, humidity, temperature, vibration, sound. So all these things we have connected via the breadboard through the Arduino controller. Now we have done a little bit more changes. We have actually connected a Bluetooth device. If you see here, there's a Bluetooth module which is actually connected to the Arduino board. So we don't have to connect direct connect. There needs to be no physical connection to the. So now this is actually fully portable. It can be taken to any place. Right now we have connected to our power supply, but this is no longer needed at all. We can actually connect with a battery here, and it actually don't need any power supply or physical power supply at all. So we have converted into a fully portable device. So let me show you how or test the data out for. So right now we are actually testing for a 4-vehicle engine. So let me just select that, and I will start the data connection now. So as soon as I click on the start data collection button, it will start taking the live data from the device, which is basically we are actually getting the data from the device via Bluetooth. So you can see here how much data points it has already taken, and it will even give you what is the average value that we are getting here. So if you see here, we are even displaying what is the average sound, vibration, temperature, and the humidity values. So if we come down, you can even see the graph plotted for each across the time. So there is sound versus time, vibration versus time, humidity and temperature versus time. And if I come a little bit down, you can see the entire data table here. This is a data frame which we are trying to capture. So the entire value, you can see how many whatever the value is actually collecting. You can see it is getting incremented one by one. Right now, let me just stop this data collection, and using different algorithms, we can actually choose what we actually want to predict. So we have actually implemented for this particular vehicle or any. We have basically collected data for these 3 devices as of now. So for these 3 devices, we have implemented all these 5 algorithms. So let me select KNN algorithm first. And now if you see, when I click on the complete button, it is actually showing the results as good. So this particular vehicle engine does not need any maintenance.